Good morning, ma'am.
Good morning, ma'am. Good morning.
Yes, yes. Yeah, thank you. Thank you for a good intro. And good morning to one and all. So, shall we start the session? Yes. And just, yes. So, just press on my screen. Hope you can visible my screen. Is it visible to you? Yes. Yeah, thank you. So, first of all, very good morning to another here. Myself, Dr. K. M. Kumar, Associate Professor from Mangalam College of Engineering. And today we are going to discuss about the topic. All you know about this, I think so. Geopolymer concrete, a future aspects and research. And before getting into the theme or topic, we have to know why. What is the importance of geopolymer concrete, and where and what is the research is going on as of now, and what are the gaps we have, and where we can work out, and where we can do our research, and what are the benefits, and what are the key aspects we have. So those things we will discuss today. So I don't take much more time of you. So I'll find out as soon as possible. So first we have to means understand, and we have to address the solution that is most major solution which the world's facing, that is pollution, right? So majorly industries like our construction industries and other industries and power supply industries, steels, then aluminum industries, all over the industries. Whenever we are producing a good product, there will be a again we have some wastages for the production of that good product. So wastage is the common nature, and obviously if the production is increasing, the wastage is also increasing. But here, what the thing is happening here, the waste which are produced to produce the good product are dumped in land, means it's thrown as the waste. There is no perfect utilization of those waste. So that is the thing we have to address, and that is the most important parameter which creates the pollution. So we have to address those things, and we have to utilize those waste products into an innovative solution. That is the thing which is moving around the world. The researchers are going around for finding a perfect way to utilize those waste into a perfect way. That is the thing which is going on. And here in our Indian cement industry, we are using limestone, then we are using gypsum, all those things, and we are using fly ash. Everything we are using, and we are producing cement. That is also leads to CO2. Means the production itself, there is an emission of air pollution, as well as we are creating land pollution by dumping the waste into the land, and we are polluting the water also, because we need to use the water in case of using machineries. So how we can reduce these waste, and how we can reduce this pollution which we are creating to this uh, earth, right? So that is the thing we have to look on it. So here some of the pictorial representation for the pollution which we are causing to this world by the industries. So first is Indian cement industry and thermal power plants. Power is the most important research which we need to sustain. Obviously, next to the water, cement is the most consumption, and power is also most consumption, right? So we need to look out on those things. And again, iron and steel sector. So that is the most important industry which creating most pollution. Because of creation of iron itself, we have to heat the core, and we have to take the iron. So there is a more emission of CO2. In this, first we have to look out about the scenario of Indian cement industry. Around 130 large cement plants are there in our India, and 300 mini cement plants are there. And we are the most third largest user of coal, right? Coal is nothing but the fuel which is required to produce the cement. Obviously, this is the data which we are using. This is taken on 16. So I'm talking about 10 years back, a decade back, right? So we are now reaching to 25. And 10 years back, this is the data which we are using. So 282.779 million tons of coal is used. And in the 17 alone, it is 407 million tons. It is increased to 407. Now think of it how much coal we are using, because cement is the most important thing which is needed for the construction. We are using more wisely, and there is an usage of cement and requirement of cement is there. So we have to produce the cement as that of what we need. That much we have to produce. No, so there will be obviously there will be usage of coal. There will be usage of uh, means creation of pollution to the environment. Again, here, the cement industry, what we are using as a material for the production of cement is a natural resource. That is, one is limestone, and 2 tons of raw materials which are taken from the nature for the production of cement. And in this, we are taking from nature. And what is we are giving to the nature again is 0.87 tons of CO2 for the by the production of cement, and 3 kg of nitrogen oxide. This is what we are giving back to the nature. So how we have to look on it. And again, what are the relative common building materials we are using? From this, you can understood around 15 billion tons per year of concrete is used wisely among all those construction materials like wood, steel, asphalt, glass, brick, aluminium. In those things, concrete and cement is the most widely used material in construction industry. Again, this is the pictorial representation for your better understanding. So concrete versus cement. So in this, how much cement is using? We are using in concrete. How much cement is there? So 11% of cement is used in concrete, 1 meter, 1 meter cube, for example. And in the cement, how much clinker is there and how much other substitutions are there? Around here again, 78% of clinker is there in the 1 meter cube of concrete, 1 meter cube of cement. So in the clinker also, how much is raw material and how much is limestone? So clinker is, we know, all know, it's a production of burning limestone, right? So this is what clinker we know. So in that 80% of limestone we are using. So think of it, in the concrete only 11% is cement. In that 11% we are using 80% of limestone. Again, coming to gravel and sand, that is also natural resource we are using. That is also we are using nature, and water is also nature, air is also nature. Everything we are taking from nature, but what is the thing which is be given back to the nature is again pollution, right? So this is what are the CO2 emission in cement industries and cement manufacture. So for the limestone calcination, it is takes 535 kg per ton for ton of clinker, and CO2 from fuels, right? Fuels alone we have to take 330 kg per ton per clinker per ton of clinker, and direct CO2 emission from clinker, right? So direct CO2 emission, that is 865 kg per ton of clinker. So totally average of 70% what we have looked back now in that. So calculating that 78%, we have to come around 68 kg per ton of cement, uh, which we need while the production of 1 ton of cement. So for the production of 1 ton of cement, we are using around uh, 680 680 kg per ton of cement. We are uh, producing a CO2, right? Yes. So next, what is the main look? Yes. So what is the main we are levers to reduce CO2 emission? First, we have to go for energy efficiency. Again, we have to move for alternate fuels, or we have to go for clinker substitution, or else we have to replace the cement utilization in concrete. This is what we can produce. So here again, already. Again, this is again the another one waste material which we are producing a large amount, right? So again, thermal power plants. This is the most term which we are using for generation of power. We are having more systems for power generation. Obviously, in this is the most important, most efficient one, and most useful one, right? So we are use wisely. Again, the thermal power plants we are using first largest user of coal in the industry. 70% of total electricity in the world we are producing using TPP, using thermal power plants alone. Again, in that 40% of ash is produced from the generation of power. So waste which is produced from the power generation. So here in cement we are using 78% of clinker. Here we are using 40% of fly ash we are producing as a waste. So again, in iron and steel industry, so obviously I told you know, in the second largest coal user in industry, in this we are producing waste as a byproduct of GGPS. So this is one of the GGPS. And coming to this, what we are using as of now as a cement, that is a major pollutant. And what is the major use of human being by our world is electricity, which is produced using power plants. And what is the most consumption or most useful product, steel or aluminium? From that industries also we are producing waste. So everything we are depleting in nature. Not at all we are doing any environmental or eco-friendly things. So how to overcome these dispose and how to reduce the usage of cement. So for this, we have to move on to next level, that is geopolymer concrete. So all you know, I think, what is geopolymer concrete, and I know you know about and you can hear about geopolymer. So geopolymer is nothing but alkali activated concrete, alkali activated paste or alkali activated gel. So this is what is nothing but a polymerization gel, an innovative material that is characterized by long chain networks of inorganic molecules and potential alternative which can be replaced for cement also. Again, see, you can compare this OPC and PPC, right? You can compare this OPC and PPC. In OPC, we can produce by adding cement with water, right? By adding cement with water, we can produce CSH gel. I think you know what is CSH gel. That is cement, calcium, aluminosilicate hydrate gel. Either it can be CASH or CSH gel, right? So CASH gel, we can use this CASH gel, right? This is the production of hydration. Hydration is nothing but activating the cement or activating this cement particles or chemicals compounds present in the cement by using water, right? But here in GPC, what we are doing, think of it. If you are adding fly ash with water, what will happen? Nothing. The fly ash will float alone in the water that is not mixed well. So we have to mix and we have to produce a paste, right? So for production of paste, we have to activate the composition which is present in the fly ash by using some activators. This is what we are doing in the alkaline activation. Obviously, fly ash with some amount of water for the fluidity and adding some alkaline activators, and we can produce the cement paste, right? Sorry, geopolymer paste. That is also known as geopolymer cement. It is also called as geopolymer cement. Again, here you can see coarse aggregate is there, fine aggregate, admixtures. In case of if you need to improve any properties, you can use admixtures. This geopolymer cement is what I told. Geopolymer cement is nothing but fly ash plus alkaline activator. Alkaline activator. You can get this geopolymer cement. Water is not required in case of any uh, thing is there, right? Any fluidity or any viscosity, if you need it, you can add water. So further, you can produce GPC, right? Again, here, what are the constitutions we are using? Coarse aggregate, fine aggregate, admixtures. If you need any increase in fluidity or viscosity or slump of the concrete, you can use the admixtures. But obviously, like a cement, like as OPC, we don't need compulsory superposition. We don't need of that because if in the gel structure itself, there will be some fluidities there. That is enough for the slump based mix. In case if you want to produce a self compacting mix, At the time, you have to add these water reducing admixtures or water repellent admixtures, right? Again, here coming here, this is the most important term which we need to know: geopolymer. So how it can be produced, how it is generated, how the polymeric chains are there. So these are the things which is explained here. Again, in the fly ash, we have SiO2, right? SiO2 and Al2O3, right? So I think you know what is SiO2 and Al2O3. Nothing but silicon dioxide and aluminum oxide. The material which is having SiO2 and Al2O3, right? The material which is having SiO2 and Al2O3 can be used as an binder or aluminosilicate source material, right? But whichever the material, whichever the waste, whichever the industrial bioproducts that is having silica and alumina, SiO2 and Al2O3, that can be used as binder or aluminosilicate source material in the geopolymer family. Right? Coming to here, geopolymer is a aluminosilicate based polymer. That is, I told you, Si and Al is the most important parameter we required for the creation of polymeric chain. So if the Si and Al is the ratio between the Si and Al, for example, in my fly ash, so fly ash, you have to know fly ash which is taken from different resources and different countries or different places. That is not same. That is not having same property or same composition. Each one have different composition and different properties, right? So in case my Si and Al in my fly ash is equal to one, this is the chain which is formed, right? So silica will be there and alumina will be there. In between those, an O bond will be created, oxygen bond will be there. Again, this OH, how this OH can come and it can occupy this. So this is what we have to understand, how these OHs are generated, how it creates bond. This is the alumino, sorry, this is alkaline activators from NaOH and KOH, right? From NaOH and KOH, these OHs are coming, right? So for that only we need uh, aluminum, see, alkaline activators, right? So again, coming to here, I'm having SiO2 and Al2O3, right? And that is incorporated in the ash. How I can split, how I can dilute, right? So for the dissolution, we are using alkaline activators and strong alkaline activators. That is, we will see what are the activators which we are using. So this OH is coming from the activator, right? Again, here, if my Si and Al is ratio is equal to 2, so this is the bond which is creating inside this. So SiOH and AlOH. If your Si and Al ratio is 2, right? Again, this can be created, that is ortho silate siloxo, right? So this is one type of bond which can be created. This is the third bond which is created, right? If your Si and Al is range is equal to 2, and if your Si Al ratio is equal to 3, and this is the bond which can be created. This is number 4, and again that can be rearranged. This is formed as fifth, right? This is the polymeric chain which is formed in fifth chain, right? So this is inside which is happening inside the geopolymer concrete. And here we need to know what are the constitutions of geopolymer, what are the components, and what are the ingredients which we are using in the geopolymer, how we can prepare the geopolymer, right? So first and foremost, we have to know what the source material. And already told aluminosilicate material. Aluminosilicate material is nothing but the waste byproduct which is having aluminum and silica that can be used as aluminosilicate source materials, right? Aluminosilicate source material or binder, right? Again, alkaline activators or alkaline liquids. This is either combination of sodium hydroxide and sodium silicate or potassium hydroxide and potassium silicate, right? Either should be both the Na, right? Both the Na terms, NaOH and Na2SiO3, both the Na terms, or else it can be potassium hydroxide and potassium silicate, right? Source material rich in aluminum silicate, that is fly ash or another anyone, any other binders that can be added with the alkaline liquids, that is alkaline silicates and hydroxide plus distilled water. Why this distilled water is used? To change the hydroxide NaOH pellets to NaOH pellets into fluid form. For that, we are using distilled water again, and one more extra water can be added to improve the fluidity of the mix, right? So for that also we can use the distilled water. From this we can produce the geopolymer concrete. Here I have to come to say that we have two types of geopolymer. First one is two-part geopolymer, right? So first one is two-part geopolymer, and second one is one-part geopolymer, right? So you have to know what is the difference between two-part and one-part. I think some of you know about this. Two-part geopolymer or one-part geopolymer is nothing but what we are using here is two-part geopolymer, right? What we are up to this what we have seen is two-part geopolymer. That is, source material will be there. Two types of alkaline activators, either hydroxide based and sodium silicate based activators will be there. Hydroxide based and silicate based activators will be there. By using these two alkaline type activators, if you are activating the source material, the geopolymer gel which is produced from these is called as two-part geopolymer, right? So two-part is nothing but one will be in powder form, one will be in powder form, that is binder will be in powder form, and the solution will be in solution form or liquid form, whatever it may be, right? So powder binder will be in powder form, solution alkaline activators will be in the solution or liquid form. So this is also termed as a two-part geopolymer. By the way, in one-part geopolymer, two things will be in powder form, that is binder as well as alkaline activator. Binder plus activator will be in powder form. We have to add extra water. We have to add water to activate this, right? So this is one-part geopolymer, whereas this is the trendy research which is going around the world as of now. One-part geopolymer focusing is going on, and research is going on into the depth, to the core. People are watching about one-part geopolymer and what are the terms we can change, what are the things we can change, and what are the research gaps we have already. So those things people are looking around it. So in case if anybody is doing in geopolymer research in geopolymer, you can just look out about this one-part geopolymer, right? In this one-part geopolymer, why this one-part geopolymer is most important means that gel or a concrete produced from this using this one-part geopolymer is same as that of cement, right? So same as that of OPC concrete. Why means in OPC also we are using cement plus water, and finally if needed, finally the mixing process will be easy, and final we will get a paste, cement paste. Then if you need we can add aggregates. Again it can be termed as OPC, right? Ordinary Portland cement concrete species, right? Again, here in this one-part geopolymer also, binder will be in powder, alkaline activator will be in powder. You just add water. If you need add aggregates, that will be termed as again one strong concrete. Okay, so this is what uh, things are going. So we have to look out about two types of geopolymers. First is two-part, and again is one-part. Again, we have seen all those things, how the chains are uh, created, right? And coming here, what are the source materials we can use, and what is the necessity of those things, right? So again, aluminosilicates, whereas calcined clays, calanoid clays, volcanic rocks, mine tiling, industrial byproducts like fly ash, silica fume, GGBS, rice cash, red mud, slag, everything will be as used as aluminosilicate source material. Obviously, here also some of the byproducts, I can name it as rices, silica fume, which are rich in silica that can be used as an alkaline activator. Those research is also going on, like by using those rich silica material as an alkaline activator, they are producing geopolymers. Again, coming to alkaline liquids from means chemical refineries, that is NaOH and KOH, and Na2CO3 and K2CO3, sodium silicate and sodium potassium. So both the things will mix together and polymerization happen inside the thing and geopolymer cement is produced. Again, this polymerization, this is the most important thing which happen, which needs to be looked out in geopolymer concrete. How this happened, and there is any requirement of temperature for this, and there is any requirement of controlled conditions there for creation of polymerization. That is the main question. Obviously, geopolymer is first invented by David. While the professor introduces using fly ash as an aluminosilicate binder, and he is adding alkaline activators, right? Alkaline activator solutions, and that mix together and form an gel, but it not hardens. It not hardens. It will be in the pasty nature. So he used to cure the samples by heat curing, elevated temperature curing, for just pre-activating the polymerization in a speedy way. So he has done and he has achieved the polymerization. He has finally get the geopolymer concrete. Why I'm telling this? Elevator temperatures are required only for the fly ash. If you are using fly ash as your aluminosilicate source material, elevated temperature curing is required. Whereas if you are using other binders like GGPS or any other things, you don't need elevated temperature curing. Why? What does the reason be in this? There is a simple reason. If in case of fly ash also, you don't need elevated temperature if your fly ash is having calcium, right? If your fly ash is having high amount of calcium, that is not required for elevated temperature curing. Why? Because calcium is highly reactive in nature. So it will easily and highly reactive with the alkaline solution and produces Ca, sorry, calcium aluminosilicate hydrate gel. This is the hydrated gel which we can see it in cement also. So you can understand this. Structure like cement paste, we can get it in geopolymer also in case if your aluminate silicate is having high calcium. Obviously, there will be a drawback of having high calcium. I will tell you one by one. So first we have to see what are the advantages of having high calcium. If the thing is having high calcium, you can your gel production from the high calcium aluminosilicate source material will be calcium aluminosilicate source silicate hydrate gel. In case if you doesn't have this CAS gel, your your aluminosilicate source material is not having calcium that much. That gel which is produced finally from the after the polymerization will be sodium aluminosilicate hydrate gel NaSH, right? Sodium aluminosilicate hydrate gel. If you are using sodium hydrate as an alkaline activator, if you are using sodium hydroxide as sodium silicate, you can get NaSH gel. If you are using potassium K, right, you can get KaSH gel. That is the difference. So potassium aluminosilicate hydrate gel, nothing but in the polymerization gel itself, the final term that Na can add into the bond and it will strengthen the structure. That structure will be changed into solid. Okay. So again here, what are the materials which we are using? I told you no, it can create the hardened binder material like cement. So how it can be like that of cement? This is the thing is happening. In cement, we can have CHS gel. Here we can have NaSH gel or KASH gel. Even there will be a CHS also in case if we are having our aluminosilicate binder having calcium rich, right? So here again, what are the categories of geopolymer? Slag-based geopolymer, rock-based geopolymer, fly ash-based geopolymer, ferrocyanide-based geopolymer. In this fly ash-based geopolymer, alkali activated fly ash geopolymer will be there. I think no much. We don't want to discuss much more about this. Slag-based geopolymer, we are using blast as an GG-based as an one of the binder. You can call it a slag-based geopolymer. And rock-based geopolymer, if you are using volcanic stuffs and mine tailings, you can call it as rock-based geopolymer cement. And again, fly ash based geopolymer. Here, can use alkali activated fly ash based geopolymer. I told you, no, we need elevated temperature curing, that after casting of cement, we have to heat the samples for some times or for some duration to activate those materials to get the polymerization reaction. So we can use NaOH and sodium silicate gel. So after that we can get an geopolymer gel, right? Here I told you, know, in slag and fly ash based geopolymer, GGBS will be there, and fly ash or aluminum silicate source material will be there. Sodium silicate and sodium hydroxide solution will be there. Here you can see calcium polysilate silaxo, that is nothing but CaSH, right? Calcium aluminosilicate hydrate gel, and K is nothing but either K can be termed as potassium. So NaSH gel. Okay. So this is what produced from slag fly ash based geopolymer. Why? Because the GGB is having high calcium, right? So your mix or your source material having high calcium, then the production reaction product will be having calcium aluminosilicate hydrate gel and sodium aluminosilicate hydrate gel. Okay, right. Here it is ferrocyanide based geopolymer in case of using high Fe2O3, because whereas in the aluminosilicate source material, I told you, know, what we need is SiO2 and Al2O3. So we cannot come to the conclusion, whereas the fly ash or GGBS, what are the materials we are using, that is not only having the silicon alumina, that is also having ferric, Fe2O3, MgO, CaO, lot of components will be there. In case if we are using high Fe2O3 content material, that can be termed as ferrocyanide based geopolymer. It's nothing but like as Ca, there will be FeSN gel, ferro aluminosilicate hydride gel will be formed. Obviously, we don't have that much Fe2O3 content in any of the source material. So, but the reaction product can be there. In case in some of the microstructure, you can analyze, you can see, you can check, and you can see some of the ferrocyanide based geopolymer gel is there. Okay, and coming to here, comparison between what is the conventional plain cement concrete and geopolymer plain cement concrete. So curing and strength, 28 days strength is in curing and strength. Conventional cement concrete, 28 days strength period is required for curing and strength gain. Here, and one more thing I forgot to tell, in case if you are using this Ca based mixture, no, in case if you are using Ca based mixture, here you have to heat the samples. Here you can keep the samples in the ambient temperature. Mean you don't need to cure the samples using water. But in plain cement concrete, we have to cure the samples in water, but here it is not required. We can cure the samples in ambient curing, right? So again, it cure more rapidly and gain more strength within 24 hours. So obviously, you can check more of the literatures. You can find this. The convention means comparison of strength between these two things. Geopolymer can attain its strength within 3 days. Maximum 3 days, it will attain its 28 days strength comparatively to cement, right? And setting period sets rapidly. And means conventional cement will set rapidly and retards while transporting. Here it is slowly set. In case of fly ash based mix, it is slowly set. So it can be useful in case of transportation, right? And reaction with the fine and coarse aggregate. So it creates strong chemical bond. Here it is same as the tough. There is no change between this. Only thing is here we can use cement paste, and here we have to use geopolymer paste. That's it. Okay. And again, here you can see hardening of paste. Already we have discussed a lot of things. Here in the hardening after hydration, you can see calcium silicate hydration, CSHS. That is CASH also, it can be called a CASHS. So this is which can see in OPC. So calcium disilicate and hydration, that can be called as calcium silicate hydrate. This is what which is formed, and the same like structure you can see here, but here you can see lot of water molecules there. Here don't no need of water molecules. Only need is this K. K is nothing but either it can be Na or K. In this they are representing in using potassium. In case if it is sodium based, here it can be only sodium. That's it. So here it forms like this polycondensation. Again, it is termed as polysalicylate fluxo, right? So this is the microstructure of OPC and GPC. You can see here how there will be a lot of how the structure is look like and how the gel structure, how it is. You can see lot of pores and lot of cracks. All the things can be there in the OPC based structure. Again, here you can see pores will be there, but the dense mix, how it is dense, you can see. The gel which is formed in GPC is more dense than OPC. That's why it is giving more strength, right? It is giving more strength in the early age itself, right? Again, as a researcher, we have to concentrate on the flaws also. So in the GPC, we have a lot of flaws. I will say one by one, right? So first we will see one by one as a advantages. Then we will see to the research gap that we have. So again, the same thing. Advantages is high compression and tension, low creep and shrinkage, resistance to heat and cold, very strong chemical reaction, chemical resistance, and ductility factor will be more. Sorry, will be less, and stiffness will be more, right? So how it is reducing CO2 emission. So this is for cement and this is for GPC. So how it is reducing the CO2 emission in the environment if you are using GPC, right? So where it is available. So already it is implemented. Geopolymer concrete is implemented already. So nothing where it is in British company. So Banch jumped up as a geopolymer cement. They already registered as a product, and the Australian company Zuband is already created Ecrete as a geopolymer cement. The name is Ecrete, and North American geopolymer application is blended Portland geopolymer cement, as known as Pyramid. You can see, and that is patented in 1984 itself, right? So where we can apply this concrete pipes, pavements, structural elements, retaining wall, everything everywhere we can apply. So this is the existing application where they have built an aircraft, built an landing for aircraft takeoff, and this is using pyramid. In the US, they have created a pavement using geopolymer cement, right? So this is one university which is already created and constructed using geopolymer concrete. So Queensland University, you can see and check it in uh, website. And this is flag flyers with geopolymer concrete floor pots, which is already implemented. And the greenest airport in the world, Wellcamp Airport. And this is more than 3,000 cubic meters of lowest carbon cement-free geopolymer concrete. And future scope of GPC where we can use the GPC, that is transportation and construction offshore applications. And again, coming here, what are the problems we have in GPC and what are the solutions we can term it as research aspects. Now we are getting into just an discussion about this, right? So whereas now you can get an idea about what is GPC and what are the elements in GPC, what are the ingredients are there, everything, what are the properties. Obviously, it will be great performance in all these 10 characteristics compared to OPC. However, coming to here, GPC is produced using chemicals. First drawback is applicability, right? So whereas in cement, we can the workers, we have to think it in a workers mindset that will be easily uh, applicable, but geopolymer cannot be applicable because the strength and whatever the parameters we are measuring in GPC all is based on the ingredients and the like aluminosilicate source material, quantity of aluminosilicate source material, quantity of chemical composition present in that, and quantity of NaOH, how much we are using, what is the molarity of NaOH, and what is the quantity of Na2SiO3 we are using, what is the ratio between NaOH and Na2SiO3, and how much amount of water we are adding. So lot of things are there. These are all the parameters we have to decide, and that are all the parameters which decides the strength and behavior of geopolymer, obviously. And normal worker cannot implement those things, cannot use those things, cannot use those chemicals by these configurations, right? So we have to simplify the applicability of the geopolymer concrete. That's why they have imported one part geopolymer concrete, right? And the second one, whereas if you are using chemical activators, already concrete is highly reactable to chemicals, right? Concrete is already highly reactable to chemicals, but we are reproducing concrete using chemicals. Again, there will be a flash. Chemicals which are all present in the inside the concrete will loosen its durability. So we have to look about that. Alkalis. Alkalis are the most important parameters in GPC because in cement concrete itself, we are focusing on ASR, alkali silica reaction, and AR, alkali aggregate reaction, right? So in case in geopolymer in cement, we are having less alkalis only from aggregate, but here and cement, small amount of alkalis are there. Here we are using more quantum of alkalis that can lead to heavy ASR and AR. So how we can reduce those AR and ASR? That is the research we have to address. Again, coming to here, corrosion. So corrosion is the most important term in OPC as well as in GPC. And we know what are the factors which will leads to corrosion, right? The same factors which applicable for OPC is for also GPC, right? Whereas first one is ingredients, inert materials, and environmental factors, and then other behaviors. So these are all the major three reasons for corrosion. Like us here also, in GPC we are using chemicals, and the environmentals also will react with the chemicals that can produce that can leads to high corrosion. So corrosive environment will be there. We have to look out those things. Again, already this is found one fly ash based GPC alternative for fly ash. They are using GGPS, and GGPS based geopolymers also having drawback that it can set fastly, right? Comparatively, uh, means what we can say, if you are adding water into the, if you are adding solution into the GGPS, alkaline solution into the GGPS, they can set within a fraction of second. Means the calcium is highly reactive, so it can create much impact on that, and the gel structure will be formed in immediate after addition of solution. That is not a feasible one because if like this, we cannot cast the concrete into an samples or into an specimens, right? Where whenever there will be some limited time, some limited settings, some limited hardening time is required for us as an concrete, for an concrete to place the concrete into an sample or specimen. Okay, so that is a drawback. So again, that is also found one. They have uh, prolonged the setting of GGBS based geopolymer by adding some fly ash and adding some metacoline and add water that will produce a calcium silicate and that produces calcium silicate hydrate gel. So goes on. There is no unreacted particles. There is less amount of unreacted particles. By the way, in GPC, there are high numbers of unreacted particles are there inside the concrete medium. Means silica which we are adding because the dissolution of chemical composition, chemical compounds from the alkaline source materials are not reactive with the alkaline medium. Means, for example, if I am having 100 molecules of silica, that 100 molecules of silica are diluted from the fly ash, and in the 100 silica molecules, only 70 molecules are reacted with alkalis and created a polymer chain. Other 30 molecules of silica are rest as unreacted. What is the thing is that nothing that will leads to lot of durability issues because in case if any environmental factors affecting inside the concrete medium that will easily react with the unreacted silica or unreacted particles, any other particles. I mean, same as an example in case of silica, right? In case of any other unreacted particles, that will easily react with the environmental factors. For example, CO2 is coming inside, right? Carbon dioxide is coming inside. That will easily react with the carbon dioxide, and that can cause lot of damages to the concrete medium inside the concrete medium. In case chlorine is there, in case chlorine is entered into the medium, that can react with the silica or so Na alkali, right? That can create most dangerous problem. So the research we have to focus is now how we can reduce the unreacted particles or how we can make all the molecules or all the particles or the uh, silicate means aluminum silicate source materials to and reacted particles, right? That is the research. So geopolymer research is not now it is not based on the outer side. We have to go into the chemical nature and we have to focus on chemical study. We have to do uh, microstructural studies, right? Microstructural studies using FTAR, XRD, XRF, and other TGA, all those things, right? So this is how we have to focus on. Coming to here in one part geopolymer, that is the applicability. So applicable is one part geopolymer. So we have to focus on one part geopolymer. Obviously, in one part geopolymer, here now there is a lot of problems are identified and one part geopolymer is implemented. In one part geopolymer, there is a lot of solutions are there like potassium carbonate, potassium silicate alone, sodium hydroxide alone, cleaning solution, coffee cash, rice cash, then soda ash, everything which is highly having sodium or potassium as an composition that can be added as an alkaline activator, right? So one part geopolymer is not only based on only one, right? Only whether it can be NaOH or Na2O3, not like that. Which material now the research is going on in this way? Which material is having potassium or sodium or high alkaline in its in its nature, in its composition, that can be yes. Sorry. Uh, means what I was saying, right? In one part geopolymer is not only based on sodium silicate or sodium hydroxide or potassium silicate and potassium hydroxide. The material which is having an Na or K, right, in its composition that can be used as alkaline activator, and that is the research is going on. And obviously, we have to uh, look out in, for example, if we are having wood ash, in wood ash we are having potassium, right? K2O is highly higher in wood ash and corn ash, but here there will be a problem like how to get the K out of it, right? How to get the K out of it. That is the thing we have to focus on. and there will be a lot of ways there. First one is calcination. So if you are calcinating this wood ash, and that can be term out this O out of that, and K2 will be there. Again, you have to react with the water, that can be termed as KOH, right? But these are all the unproven research. I'm suggesting you to do a research on this, but we can focus on these things. How we can take an alkaline activator from the naturally available materials, right? So this is what we have to focus on, right? And again, how long the scientific papers are publishing in uh, geopolymer, right? In keyword alone. So here, what are the research aspect we have? So availability of source material. So you have to change your source material, and you have to use the source material as an alkaline activator also. What are the waste byproducts we have? Already I told you, no, wood ash and coffee as cash. And then what are the material which is having, these are the material which is high in K2O and corner bash, right? Corner bash, CH again, corner bash, and baggage is not having much K2O. So which are all the material having K2O? We can use those materials and those materials in as an alkaline activator, alkaline solution. By the way, before using this, we have to pre-treat this materials. We have to pre-treat this material. We have to pre-treat using calcination or some other treatment methods to get out this K2 from this K2O, right? So the dissolution of K2O. Again, drawbacks in each silicate materials, finding various alternatives. Like I told you, know, in calcium-rich materials like GGPS, that is having high and speedy setting. So we have to reduce those setting time by altering some amount of GGBs with other materials. So already done. And how to handle the harmful chemicals by the applicability of the geopolymer concrete and skilled labor. So you have to lean the construction method so that laborers can easily understand what they are doing, right? And curing methods, nothing. You have to move up with the uh, ambient curing, right? So this is what we can do. And again, I told you, later age strength attainment is nothing but, whereas all the strength attained on the early age, there is no strength development in the later age, right? So I told you, know, in GPC, within 3 days, the strength will be developed. So after that, there is no strength development, means there is no reaction, right? There is no reaction. Every reaction can happen within 3 days. So the thing is that there is no reaction will happen inside the concrete medium. So there is no strength development. The concrete should not be like that. That should be develop its strength for the lifetime, right? So that is the thing. So you can do it in case of any uh, help in doing research in geopolymer concrete. You can get in touch with me, and please focus on the material side. Don't focus on the behaviors and property, right? So just focus on the materials and change the materials so you can understand the basic mechanism of geopolymer, and based on that you can choose the material where we can change the material, and you just go to in depth about the material characterization analysis, right? So that you can get an solution for the problem, right? For the applicability problem, right? So I hope I have shared whatever I know. So in case if you have any doubts, you can ask me. Yes, ma'am. Yes, thank you. Thank you. Thank you. Thank you. Thank you. Sure, sure, sure. Thank you.